All right, so where are we? Let's talk about historical significance for a minute, please. So I am going to try and convince you that we're at this edge, this cusp, this edge of a new era in computing, right? So if you think about this from the mid-1900s through to today, you had computers the size of a house, a bus, a desk, and now you've got maybe a computer in your hearing aid or in your mobile phone or in your watch that's always on, always connected with high-speed internet. Starting in the 1960s, maybe with ARPANET and DARPANET and some of these bits where you could get information out. Bulletin board systems, universities were connected to the network. Maybe through the 80s, bulletin board systems. Through the 90s, World Wide Web, Encyclopedia Britannica, online encyclopedia of data, and then Google indexing. The best search engine coming out of the 90s was Google with their new indexing strategy and how they were optimizing search results. Today, you can ask your phone, "Hey Siri, what's the weather tomorrow?" And Siri will read the web for you and answer your question. So that's the readable web all the way up to today. The writable web, starting with maybe bulletin board systems where you could actually contribute some content, open source software movement, free software foundation, being able to put data into the web, being able to put your own websites online, and then obviously Twitter, Facebook, TikTok, all the way until the latest and greatest of the ability to kind of do whatever you want with the web, where I can grab a cell phone and start recording myself and publish online instantly. And then finally, the trusted web, starting arguably 1976 with a paper about Diffie-Hellman key exchange crediting Merkle with this idea of how do you move secrets in public? How can I take something that's secret and give it to you while everybody's watching? How do I do that? Especially if people are trying to get our secrets. How do I do that? How do I figure that out? So that's what they came up with. And then CHOM in the 80s, and then into maybe Hashcash and B-Money and some of these other experiments with trying to figure out how we can trust the web, all the way until Bitcoin as blockchain, say generation 1, and then Ethereum blockchain generation 2, and now with a number of organizations, including Near, in this generation 3 of blockchain. So that's the trusted web. So all of these things are converging now. And today you have decentralized autonomous organizations, token economics and mechanism design. How do you get people to behave in certain ways? How do you, remove all the middlemen, disintermediation? How do you get the middlemen out, the banks out, and other systems out of the way, so that we can work together by trusting the network? Basically, that's the idea. And there's some links in here. You can certainly take a look at this. So what is Bitcoin? It's basically this final thing here: cryptographically verifiable transactions plus decentralized storage and compute, and then a public ledger. So these three ingredients, you mix them together, you get Bitcoin. Ethereum is that same technology, and then on top of it, we put this Turing complete virtual machine, a computer, basically. We can simulate any machine with this machine. It's a place where we can run contracts. That's what Ethereum is on top of this. And then the inputs to this machine are code and data from the blockchain, from this base layer. And the output data is also saved to the blockchain. So that's Ethereum. But there's some problems. It's expensive, there's low throughput, and it's hard to scale. And so to solve that, Near has tried to split out and make transactions move in parallel using shards. Polkadot uses parachains, chains that communicate with a central chain to coordinate their work. Solana, which timestamps transactions, splits them up and then merges them later. And Avalanche, which has specialized chains, one for speaking to Ethereum, one for managing value with Xchain, and then one for managing governance. And so everybody's trying to solve this problem in different ways. Near is one of those.